Let's find the average rate of change for this example. So our equation is going to be g of x is equal to 1 over 3 x cubed minus 2x plus 2. And we're going to be looking at between 2 points. And we're going to be looking at between two values of x. So when x is equal to 0 and when x is equal to 3. So our average rate of change is going to be our change in our function over the change in our inputs. So in this situation, we're looking at when g of 0 is going to equal 1 over 3, 0 cubed minus 2 times 0 plus 2, which is going to give us a value of 2. These points here, 0 times anything here is going to be 0, 0 times anything here is going to be 0, so we're just left with a value of 2. And our g of 3 is going to be equal to 1 over 3 cubed minus 2 times 3 plus 2. Looking at the 3 cubed is going to give us 27. Dividing that by 3 is going to give us 9. So 9. Now we've got 2 times 3, which is going to give us 6 plus 2. 9 minus 6 is 3 plus 2 is equal to 5. So our average rate of change is going to be the change in our function, which is going to be g of 3 minus our g of 0 over our input value, so 3 minus 0. And we've already solved these, so g of 3 is equal to 5, and our g of 0 is equal to 2 over 3. 5 minus 2 is equal to 3. 3 over 3 is equal to 1. So our average rate of change is equal to 1. Now let's have a look at this graph. This is the graph of 1 over 3 x cubed minus 2x plus 2. The 2 points that we were looking at were 0 and 2 and 3 and 5. So the average rate of change is the gradient between those 2 points. And looking at the graph, we can see that our change here is equal to 3. And the change down here is also equal to 3. So as you can see with the average rate of change between this point and this point, is that for every 1 that it goes across, it goes up 1. So even though the function changes dramatically during that, the rate of change between those 2 points on average is just 1.